In this video, I'm going to work through the answers to Worksheet 2.2. The question tells us that there are 4 waves per second, and as we know that frequency means number of waves per second, then we know that the frequency is 4 waves per second or 4 Hertz. It's important in all of these questions that you write out your working, your answers and your units for full marks. This would also be required in any exam. Since we know that t equals 1 divided by f, or time period is 1 divided by frequency, then in this case 1 divided by 4 gives us 0.25 Hertz. Again, the question here tells us that there are 32.8 waves per second, so the frequency is 32.8 Hertz. Again, t equals 1 divided by f, so we put the numbers in. 1 divided by 32.8 gives us 0.03 Hertz to 2 decimal places. Usually, if you're not sure, go to 2 decimal places or 2 significant figures, so your answers aren't too long. Here the question identifies that there are 0.25 waves per second, so frequency is 0.25 Hertz. Don't be put off by the fact that the number is less than 1. Again, we put the numbers into t equals 1 divided by f. 1 divided by 0.25 equals 4 Hertz. Here we're using the same equation, but this time rearranged so that frequency is 1 divided by the time period. Now we know the time period is 125.68 seconds, so we put the numbers into the equation. 1 divided by 125.68 gives us 0.008 Hertz. In this question, we don't need to use an equation, we're just relying on our knowledge of the word frequency and what it means. So if frequency is the number of waves per second, and we know that 32.6 waves pass in 2 seconds, then we can work out that 16.3 waves pass in 1 second. This is the definition of frequency, so frequency equals 16.3 Hertz. We're now using our other equation here, which is v equals f lambda. That little symbol there is lambda, so wave speed equals frequency multiplied by wavelength. Here we're calculating the speed, v, but we know the wavelength and the frequency. So the best way to do this is to write out the equation and then put the numbers in underneath. This is what I've done here. V equals 4.2 multiplied by 2.3, which gives us 9.66 meters per second to 2 decimal places. Don't forget the units at the end. Similarly here, again we're using v equals f lambda. We know the wavelength and frequency, so we put the numbers in. V equals 8102 multiplied by 0.021, which gives us 170.14 meters per second to 2 decimal places. We're using the same equation here, but slightly differently because we don't know the wavelength lambda. I would always recommend, as I said before, writing out the equation and then putting the numbers in next. It does save an awful lot of mistakes, particularly when we get into more complicated equations. So here underneath I've written 303, which is the wave speed, underneath v, equals 51.6 multiplied by lambda. At this point, if you get stuck with rearranging, but you've got the numbers in the equation correctly, then in an exam you would get marks because you got the physics right. You would then lose the last mark for getting the maths wrong, but you would at least leave the exam with some of your marks. So this is really important. Here I've got 303 divided by 51.6 gives me 5.87 meters to 2 decimal places. Again, we're using v equals f lambda, and I put the numbers in under the equation first. So 102.5 equals f multiplied by 0.2. I then need to divide through to get f on its own on the other side. 102.5 divided by 0.2 gives me 512.5 Hertz. So once again, I'm using v equals f lambda and I'm writing the numbers underneath first. So I've got 0.2 equals f multiplied by 1250. You'll see that at the top we're given 1.25 kilometers as the wavelength, but we must always convert to the standard units, which is meters for length. So I've multiplied that by 1,000 to give me 1,250 meters. Once again, I need to divide through to get f on its own. If you think about your maths lessons, we quite often talk about reversed doing what you've done on the first side. So on the line above, f is multiplied by 1,250. If I reverse maths it, I have to divide it on the left-hand side, hence 0.2 divided by 1250 to give me 0.00016 Hz to two significant figures. A feature of GCSE questions to make them more difficult is to have what I would sometimes call staged or layered questions, where you're asked to do two things within one question. This is a good example of that. First, you're asked to calculate the frequency of a wave and you're given its time period. We now need to go back to using the equation f equals 1 divided by t. If we put the numbers in underneath, we've got frequency equals 1 divided by 0.0012 seconds, which gives us a frequency of 833.33 Hz to two decimal places. The question then goes on to say that that wave has a wavelength of 0.35 meters and to calculate the speed. We now need to go to our second equation, v equals f lambda. Again, we put the numbers in. Remember to do this first. V in this case is velocity, which we're trying to find. We have the frequency, which is 833.33, and we're multiplying it by the wavelength 0.35. This gives us a velocity of 291.67 meters per second to two decimal places. This is a similar question, but going the other way around. So we start with v equals f lambda. The wave has a speed of 330 meters per second and a wavelength of 1.2 meters, and we're asked to find the frequency first. I've written out the equation and put the numbers underneath as before. 330 equals f multiplied by 1.2. Again, we need to get f on its own. We reverse maths and we divide by the 1.2. This gives us 330 divided by 1.2 equals frequency, which is 375 Hz. The second part of the question wants us to use that answer to find the time period of the wave. We go back to time period equals 1 divided by frequency, t equals 1 over f. We put the numbers in. 1 divided by 375 gives us 0.0027 seconds, the two significant figures. The next stage in making the questions more difficult is to ask for a layered question but not to direct you to do it. That means you've got to work out what stages you need to take. So we're told here that it takes 98.6 seconds for the wave to pass and that it travels at 0.74 meters per second, and we've got to find the wavelength. We start with what we know. We know that 98.6 seconds is how long it takes for the wave to pass, and that is the definition of time period. Therefore, time period t equals 98.6. From there, we know we can calculate frequency because frequency equals 1 divided by time period. So I'm going to do that because I think it might be useful. 1 divided by 98.6 comes out as 0.01 Hz to two decimal places. I now need the wavelength. I go to my other equation, which is v equals f lambda, and I put the numbers in underneath as usual. We know that velocity is 0.74 because we're told in the question. We know the frequency because we've just calculated that as 0.01, and we're trying to find the wavelength lambda. Again, we're going to reverse maths. 0.74 divided by 0.01 gives us 74 meters as the wavelength. So this question then is asking us to find the frequency of a ray of light with a wavelength of 0.65 times 10 to the minus 6 meters. Now, at first look, we don't appear to have enough information to answer that question because we're only given the wavelength. However, it is assumed that we know that a ray of light or anything else on the electromagnetic spectrum will travel at the speed of light, which is 3 times 10 to the 8 meters per second. So if we do know the speed of the wave and we do know its wavelength, then we can calculate its frequency using v equals f lambda. And again, I put the numbers in under the equation. This is where you need to be able to use your standard form from maths. If you're a little bit unsure about this, again, writing the numbers in first, make sure you secure your physics marks. At least then, if you make a mistake with the maths, you don't get penalised for that too. Okay, so I'm going to put the numbers in. 3 times 10 to the 8 is equal to frequency multiplied by 0.65 times 10 to the minus 6. I reverse maths this just as usual. So 3 times 10 to the 8 divided by 0.65 times 10 to the minus 6 gives me the frequency. I then put the numbers into my calculator and it gives me the answer 4.6 times 10 to the 14 meters. This is exactly the same kind of question. Again, you're only given the wavelength, so they're assuming that you know the speed of light. I write out the equation, v equals f lambda, and I put the numbers in. V is 3 times 10 to the 8. We don't know the frequency because we're calculating it, but we do know that the wavelength is 715 times 10 to the minus 9 meters. Reverse maths, 3 times 10 to the 8 divided by 715 times 10 to the minus 9 equals frequency. Don't forget at this point, if you've got all of this correct and you just muddle up the maths at the end, you've got all of your physics marks. However, if we put it into the calculator, we come out as 4.2 times 10 to the 14 meters. And a final example using exactly the same method, only this time we're calculating wavelength. Again, we know speed of light is 3 times 10 to the 8 meters per second. I write down the equation, v equals f lambda, and I put the numbers in underneath. 3 times 10 to the 8 is equal to 7.5 times 10 to the 14 multiplied by lambda, which is the wavelength, which I don't yet know. Reverse maths, 3 times 10 to the 8 divided by 7.5 times 10 to the 14 gives me the wavelength. Stick that into the calculator, and the answer comes out as 4.0 times 10 to the minus 7 meters. Finally, for those of you who find equations difficult and don't like rearranging, always come back to this simple example. We do know that 6 equals 2 times 3. I know we're all very certain of that. So when we're thinking about equations, all it means is that we're missing part of that information and need to work out what's missing. And quite often I imagine that the missing piece of information is just a box that I'm finding the answer for. So in this example, if I didn't know v, I would have a box I don't know is equal to 2 times 3. Well, we know that 2 times 3 is equal to 6, so v equals 6. In this version, the thing I don't know is f. So I've got 6 equals something I don't know multiplied by 3. So 6 equals the box times 3. Now we know that the answer going in the box is 2. If I want to work out how I get to 2, I must have done 6 divided by 3 to equal 2. So if I'm rearranging this equation, I would have to do 6 divided by 3, or in this example, v divided by lambda, to get the missing number. And finally, if the missing part of the equation is lambda, then in this example, it would be 6 equals 2 times something I don't know, and I want to know what's in the box. Again, we all know the answer is 3. So how did I get to 3? Well, I must have done 6 divided by 2. So when I rearrange the equation, it would have been v divided by f. What we need to remember is that equations are exactly the same as a simple calculation like 6 equals 2 times 3. It's just there's a bit of information missing, and we use letters to show that we don't know what that number is. If we try to see equations with letters as just the same as having a calculation with numbers, it makes it seem a little bit simpler. So if you're not sure how to rearrange your equation, come back to the basics of 6 equals 2 times 3 and see if that helps you.